Hi, let's look at what forces act on a block which is placed on a ramp as shown in this picture. You can see a purple block which is placed on the ramp as shown by this triangle, and this angle formed here, let's say, is theta, and the angle formed here between the dotted line and the other arrow shown would also be theta, because let's assume that this particular surface is along the ground initially and then we lift it up. When it is along the ground, this angle theta would be 0 here between the dotted line and the solid arrow. As it goes up, the same variation that we see here in this angle is the same angle that is formed here. So that's how this angle is theta and this is also theta. Now let's come to the surface here, and there is some friction. So we know that from previous video that there is a frictional force that is stopping the block from sliding. As we increase the slope, the block cannot slide down because there is a frictional force, static friction Fs, which is acting this way. That's why it cannot slide down. Now let's look at what the horizontal and vertical forces acting on the block are. And we'll try to find out what is the maximum angle to which this ramp can be holding the block without sliding. So we know that we when we push the block on a horizontal surface, as we keep increasing the force on the block, after it exceeds the frictional static friction force, it starts moving. Here let's find out the similar angle after which the block will start sliding. Let's split this into two parts. One is the horizontal block, horizontal forces. Let's look at the horizontal forces, and then let's also look at the vertical forces acting on the block. So we know that if the block has a mass m, mg is acting downward, the solid arrow shown downward, and normal force is normal to the plane where it is resting. This normal force is acting this way, and frictional force Fs is acting as shown. So these are the three forces. When it comes to the horizontal forces, we know Fs is horizontal in this direction, but there is also a component of mg which is in this direction. So mg is split into two perpendicular to each other, and we know that this would be mg cos theta and this would be mg sin theta, because if you take this as a triangle, then mg cos theta, this side becomes the adjacent side and this becomes the opposite side, and that's how we get mg sin theta here, mg cos theta there. So the other horizontal force which is opposing the frictional force is mg sin theta. Now as we increase theta, this value on the right hand side is going to increase and exceed frictional force at some point. That's what we need to find out. So this is all about the horizontal forces. Let's come to the vertical side of the picture. It's mg cos theta is acting downward and the normal force is acting upward. So there is no movement there, so they are balanced out. So we have two equations here, equation 1 and equation 2. When you divide equation 1, the right hand side, by the left hand side of equation 2, we get mg sin theta divided by mg cos theta equals Fs from the first equation, that is the frictional static friction, divided by n, right? But we also know that for the maximum force of Fs till which it can hold is coefficient of static friction times the normal force, mu sub s times n. This is the force up to which it can hold without sliding. In general, we write it as Fs is less than or equal to mu sub s times n, because as we keep increasing the force, at some point it will be equal to the frictional force, then it will start decreasing. So this max frictional force, Fs max, is, we know that it's mu s times n. So we can replace it here in this equation, and also mg cancels out. Sin theta by cos theta, we get tan theta equals, this we replace by mu s times n divided by n. N cancels out. So we end up getting tan theta equals the coefficient of friction. So the angle theta is nothing but tan inverse of mu s, the coefficient of friction. This means this is theta max. This is the maximum angle to which we can tilt this ramp without the block sliding down. Thank you.